What happens when a star 30 times the mass of our sun simply disappears? It leaves behind a ghost with a hunger that can swallow light itself. Imagine a place where space and time warp so violently that the laws of physics don't just bend, they break. And these are black holes, infinitely dense points that act like a cosmic waterfall. Once you cross the edge, the current of space flows inward faster than light can swim out. But these monsters are immortal. Today we're tracing the life cycle of the universe's most mysterious objects, from their violent births to their incredibly slow evaporating deaths. A black hole isn't just made, it is forged in a gravitational civil war. For millions of years, a massive star, at least 20 to 30 times the mass of our sun, lives in a delicate balance. In its core, nuclear fusion creates an outward pressure that fights against the relentless inward pull of gravity. But stars run on fuel. Eventually, the star creates iron in its core. Fusing iron consumes energy rather than creating it. In a fraction of a second, the outward pressure vanishes. Gravity wins instantly. The outer layers of the star collapse inward at a quarter of the speed of light, hit the iron core, and bounce off in a colossal explosion called a supernova. But if the remaining core is heavy enough, nothing can stop the collapse. It crushes down past the size of the Earth, past the size of a city, until it becomes a singularity, a point of infinite density and zero volume. Around this point, a boundary forms called the event horizon. This is the point of no return. While stellar black holes come from dying stars, there are monsters of a different scale, supermassive black holes. These are millions or even billions of times the mass of our sun. We find them at the heart of almost every galaxy, including our own Milky Way, a resident giant called Sagittarius, A star. Scientists are still debating how these giants grew so large, so fast. Did they start as seeds from the very first stars? Or did massive clouds of gas collapse directly into black holes? While the origin remains a mystery, their influence is undeniable. They act as the anchors for the galaxies that revolve around them. For decades, we thought black holes were eternal, that nothing could ever leave. But in 1974, Stephen Hawking changed everything. He realized that due to quantum effects near the event horizon, black holes actually leak. This is called Hawking radiation. Empty space isn't actually empty. It's bubbling with virtual particles that pop in and out of existence. Normally, they annihilate each other instantly. But at the edge of a black hole, one particle can fall in while the other escapes. To keep the universe's energy books balanced, the black hole loses a tiny bit of mass to provide the energy for that escaping particle. This means black holes are slowly, very slowly, evaporating. A black hole the mass of our sun would take 10 to the power of 67 years to disappear. That is a number so large that the current age of the universe is just a blink of an eye in comparison. But as they get smaller, they leak faster. In their final moments, they lose their remaining mass in a massive flash of gamma radiation. A final silent pop in the dark. Black holes are the ultimate recyclers. They take the matter of dying stars and over trillions of years dissolve it back into the energy of the cosmos. They are the beginning and the end of the story of light. If you could safely visit a black hole, would you look inside? Let us know in the comments. Don't forget to subscribe for more journeys into the deep dark.